Remember the chart that I had, the real numbers, and then we broke that down and we went to irrational and rational numbers. Remember talking about that like the first day of class? And rationals were integers and non-integers like the fractions. This is where we talk about that, yeah. So here, real numbers, there's actually something above real numbers. Real numbers encompass everything we've talked about so far. Above real numbers, or to the side of real numbers, we have what they call imaginary numbers. Imaginary numbers. So if you have real, you have imaginary. They use the letter I, the little cursive I, to denote that. And if you combine real numbers and imaginary numbers, you get complex numbers. The complex numbers is what everything really falls under. There's nothing after that. So you have real numbers and imaginary numbers. So what we're going to talk about in this section that we have not talked about before are these complex and imaginary numbers. All right, so so far, every time we came across the negative underneath the square root, we said you can't do that. Well, most people can't handle not being able to do it, so they make up something. So they can make it up and it's imaginary. So the square root of 36, the square root of just 36 is 6. But since this has a negative underneath it, what we're going to put is an I to denote that the negative is underneath it. And that's all that imaginary numbers is anytime you see a negative underneath the square root, you put an I on the outside. The definition of I is actually the square root of -1. Because what I could do to this problem is separate it out to 36 and -1. So that becomes 6 and that becomes I. If I wanted to get rid of this radical, we just did this. If I wanted to get rid of this radical, couldn't I just square both sides, right? So a lot of times they associate I squared with -1. Because again, let me work that out. If I squared both sides here, the square and the square root would cancel out, so I just have I squared equals -1. This is actually the one you'll have to know for in a little bit. You don't use this one very often, that I equals the square root of -1. The big thing about I know that was a little bit confusing, but the big thing about I is really all you have to do is anytime you see negative under a square root, just put I. So the square root of 100 is 10, the negative becomes I. Or what about if we were negative 50? If we were simplifying like we've been doing, so you break this down, 2 and 25, 5 and 5. So you have 5 square roots of 2, but since we have a negative there, we're going to put an I. So everything works the same way, except if you see a negative under the square root, you put an I. I should say this. Technically, the way you're supposed to write this is 5 square roots of 2 and then I, like afterwards. Technically, it's supposed to always be like this, but the reason they let you do it like this is because you don't want the square root to accidentally be. That makes sense. If I'm writing along, I don't want it to look like the I is underneath the square root. So a lot of times you write it like this. I think the computer will take it like this. This is technically the correct way, but when you're writing, it looks like the square root's under I, and that cannot happen. The I cannot be under the square root. Because the I, we're taking the negative and pulling it out. So either one of those would work. So anytime you see a negative under the square root, you put I. There's no trick or to that at all. As far as anytime we learn a new type of number, we have to talk about the operation. So we're going to go through adding, subtracting, dividing, all those real quick. You treat I just like an X. So you do everything the same like it was an X. So if I'm adding these, wait, let's talk about this first. Complex numbers, what complex numbers do is they add a real number. So this is a real number with the imaginary number I here. So they're always in this form right here of A plus BI. They will make you do it, write it in this form right here. You cannot switch those around. Like that's going to have to look like that. So now let's talk about adding and subtracting complex numbers. So adding and subtracting complex numbers, you treat it just the I, just like it's an X. So here's one complex number plus another complex number. So you just do 2 plus -3 would be -1. 3i minus 8i would be -5i. And again, treat it just like it's an X. You're just combining like terms like you would an X. Well, I will do that in a minute. So adding is just combining like terms like it's an X. Subtracting, remember what we said about subtracting? What's easier to do if we're subtracting polynomials? Change the sign of the second equation. So if I just rewrote this one as -2 minus 3i minus 5 minus 8i, change my signs here, and then you're just combining like terms like normal. So you treat the I just like it's an X. So -2 minus 5 would be -7. -3i minus 8i would be -11i. Adding and subtracting is just combining like terms. There is one catch to multiplying that makes it a little bit tougher. And that's what I just said a minute ago, was that I squared equals -1. You will need to know that I squared equals -1. So when I'm multiplying here, if I had 2i times 3 minus 8i, let's do plus. 3 plus 8i. So here, what property is this? Distributive property. So 2i times 3 would be 6i. 2i times 8i would be 16i squared. Okay, but what do we know? We know that I squared equals -1. So what we have to do, anytime we see I squared, change it to -1. So that would become -16. So I rewrite this as -16 plus 6i. All right, so he asked about FOIL. FOIL still applies on these just fine. They have one complex number times another complex number. So -4 times 8 would be -32. -4 times -2i would be +8i. -2i times 8 would be 16i. And 2i times -2i would be -4i squared. So again, I mean, that's just like it was an X, but that's no different than if it was an X. We just multiply them together. So what we're doing here, but what do we got to change? We got to change that I squared to -1, so that becomes +4. So now combine some like terms. -32 plus 4 would be -28. 8 plus 16 would be 24. Oh, what about this? All right, so you're multiplying radicals with a negative underneath. The very first thing you want to do is get rid of that negative underneath. We know what the negative means now, so what can we change this one to? 5i. Square root of 25 is 5. The negative becomes I. What's this one become? 2i. So 5i times 2i is 10i squared. Well, we know I squared is -1, so this one is actually negative 10. You cannot, if you just multiply these straight across, what do you get? You get the square root of negative 25 times negative 4 would be a positive 100, which would be 10. That way, it does not give you the right answer. Because that would be positive 10, this would be negative 10. So as soon as you see a negative under the square root, go ahead and pull it out and make it I. And subtracting. So this one, even though that has a minus right there, what is it? You'd have 6 minus 14, which is negative 8. 6. Right. So 6 to me, just it's a subtraction problem, right? So go ahead and change my sign. 6 minus 14 minus 3i. It'd be like distributing a negative. That's kind of what I did. Yeah. So 6 minus 14 is negative 8, and then minus 3i. I would say the most common answer to that one is negative 8 plus 3i. Forget to take that negative to there. What about that one? 6 minus 7i squared. What do you do on that one? You're going to end up foiling it because you got to do 6 minus 7i times itself twice. 6 minus 7i times 6 minus 7i. So 36 minus 42i, then that one would be minus 42i, and that one would be so as soon as you see that I squared, change that to negative 1, so this one would be negative 49. So combine this term with this term. Get what? Negative 13. And then these two would be negative 84. And again, make sure you write the one without the I first and then the one with the I second. Let's see what they got here. All right, they only have 2 problems on these. The dividing ones, are, well, we know I is equal to the square root of negative 1, right? Well, what do we know? We cannot have a radical in the bottom. Cannot have a radical in the bottom. So we have to multiply to get rid of that. So if this was 8 over the square root of 2, what would you multiply it by to get rid of the radical on the bottom? You do the square root of 2 times the square root of 2, right? So on this one, well, I is the square root of negative 1. We can just multiply by I. I times I would be I squared. I squared is negative 1. Well, if I multiply the bottom, now I got to multiply the top. So this would be 8i over negative 1, which is negative 8i. There's only one of those, and then there's one of these. Go to a new page. So if you have 2 terms, you remember what we multiplied when we had like x?
Yeah, conjugate.
multiply by the conjugate, right? So here, what's the conjugate of this one? 3 plus I. Multiply both sides by 3 plus I. So 2 times 3 is 6. 2 times I is 2I. And down here we got a FOIL, right? So you have 9 plus 3I. I guess we don't have to FOIL because our middle terms are going to cancel out. Negative I squared. So these cancel out, and I have 9 minus, that becomes negative 1. So it'd be 10, right? Now, probably the thing that's not fun about this is it has to be, well, what can I do first before I do anything else? I can divide all those by 2, right? So 3 plus I over 5. But it has to be in this A plus BI form. It has to look like this. So what you do is you change this to 3 divided by 5 plus, there's a 1 right here, 1 divided by 5, I. So now it's in that A plus BI form. We'll go ahead and do this one too. 8, 1 plus 6I. All right, so again, to get rid of the radical on the bottom, I have to multiply by the conjugate. What's the conjugate of this one? 1 minus 6I. So on the top, we distribute the 8. I get 8 minus 48I. On the bottom, the middle terms cancel out, so all we really need to do is 1 and 6I times negative 6I. So I'd do 1 minus 36 times negative 1, which would be 1 plus 36. So that becomes 37. But again, we got to write it in that A plus BI form, so it's 8 divided by 37 minus 48 divided by 37I. So you're just separating that out. And the very last thing in this section is called powers of I. I don't think this is on the test, but it shouldn't be. Basically, it's going through all the powers, and what happens if you have I squared is equal to negative 1. What happens if you get I cubed, or I to the 5th, or I to the 7th? So I to the 0. I to the 0. Anything to the 0 power is what? 1. Anything to the 0 power is 1. I to the first power is just I, right? I squared, we know is negative 1. We've been talking about it. So how do you find I cubed? Correct. So how'd you do that? So the thought process there is exactly what he did, is he broke it down to I squared and I. I squared and I. Well, I squared is negative 1 times I would be negative I. Okay, so what happens if you had I to the 13th? How many pairs of i's are in there? There's 6, right? There's 6 pairs. So we have I squared, there's 6 pairs, and there's 1 left over. 2 times 6 is 12, plus 1 more, right, would be 13. So this is negative 1 to the 6th power is that going to give me a negative number or a positive number? It's an even number right here, so it's going to be positive I. So this is actually I to the 13th is positive I. It's the same thing as positive I. I hate that way. I can't stand doing it that way. It doesn't make any sense to me. You have a pattern here. If you found I to the 4th, I'm going to go ahead and tell you I to the 4th is actually 1, because I squared times I squared is negative 1 times negative 1, which is positive 1. I to the 5th is I. So you see how my pattern here is 1I, negative 1I, and then it starts to repeat. 1I, negative 1I. So it's a pattern of 4. It's a pattern of 4. Well, anytime you have a pattern of 4 to figure out where you land, you can divide it by how many your pattern is. Our pattern here is 4. So if we divide it by 4, whatever our remainder is the same as our exponent. Okay? I know that doesn't make a whole lot of sense right now, but let's look at this. I to the 13th. So if I do 13 divided by 4, what's my remainder? I don't care what it actually is. What's my remainder of that? 4 times 3 is 12. My remainder is 1, right? So my remainder is 1. So that means it falls under this category right here, and the answer is I. I to the first power. So since my remainder is 1, it's I to the first, which is I. The problem right there in the book, I to the 16th. If I divide that by 4, if I do 16 divided by 4, what do I get? 4 with the remainder of 0, right? So that means it's I to the 0 power, which is 1. So that is my answer. That makes sense at all?